This is Pre-Calculus, Part 1, Section 4.4, Evaluating Trig Functions, Example 1 on page 503. So it's giving you a point, and on the terminal side of theta, that just means that that's the far point of the triangle. So for example, the easiest way to do this is actually draw the triangle. And if you do the point, and the point is -3, 5, without lifting your pencil, you actually draw the triangle. So for example, if we were going to go -3 on the x and -5 on the y, that point right there is the far side of our triangle. Not having much luck with this little pencil. Okay, so there's our triangle. This is your r. R is always the hypotenuse, the radius of the circle. Now keep in mind this is not on the unit circle because r is not going to be 1. And the definition of unit circle is that r equals 1, so be careful with that. So your x, which is your cosine value, is 3. Your y, which is your sine value, is -5. Sorry, it's not your cosine and sine value, it's the opposite and the adjacent sides. And then we have to actually calculate r, but you just do that with the Pythagorean theorem. So x squared plus y squared, and you end up with square root of 34 for r. Then you just go build your sine, cosine, tangent. Okay, so sine is opposite over adjacent, opposite over hypotenuse, which is y over r. Your opposite side of theta is always the y. Okay, so that would be -5 over square root of 34. We can't leave it like that. We have to multiply by the conjugate or the square root by itself and get -5 square root of 34 over 34. Now when you go to do the cosecant, instead of doing this and turning it over and ending up with the square root in the denominator again, remember to go back to here, because that way when you flip it, or here, depending on how you want to look at it, your square root now is on the top, and you don't have to fix it. Okay, cosine is going to be adjacent over hypotenuse. Remember the adjacent was the -3, it's always the x value. So -3 over square root of 34, and again we need to fix that. But when you do the secant, go back to here and take the reciprocal of this so that your square root ends up on top. The tangent is y over x, or opposite over adjacent, sine over cosine, however you want to look at it. So -5 over -3, which reduces to +5 over 3. And then that reciprocal, the cotangent, would just be x over y, which would be 3 over 5. Okay, so let's try the checkpoint. Okay, so for the checkpoint, it gives us the point 1, -3. Let me get rid of this. It followed us. So in this case, we're going over 1, +1 to the right, and down 3. And this would be our point right here. Okay, so our x value is 1, our y value is -3. We have to find r for a triangle with sides of 1 and 3. So that gives us square root of 10. And then it's just a matter of putting the sine, cosine, and tangent together. So sine is opposite over hypotenuse, or y over r. -3 over the square root of 10, again we need to fix. But for cosecant, we can go back to here and just reflect that one and then not have to worry about fixing it. Although I probably should have, because that negative should be in the front, not in the denominator. Apologize for that. There we go. Cosine is adjacent over hypotenuse, or x over r. So 1 over the square root of 10 multiplied by square root of 10, and you get square root of 10 over 10. For the secant, just go back to here, reflect that, and it's just square root of 10, because you don't need stuff over 1. Opposite over adjacent, or y over x, would be the -3 over the 1, which would be -3. and the cotangent would be the reciprocal of that, which would be negative 1/3.